All right. Good afternoon. It is Friday. October 22nd. We're here talking about fractions. Here we go. Decide if each of the following fractions are equivalent to 9/4. If you are watching the recording back, this might be a good place to pause, work on this, and then come back to it after the explanation once you've gotten a good answer. Just thinking out loud here. So pause if you need to work on this and then come back when you're done. Okay, we've already worked on it, so here we go. Decide if each of the fractions are equivalent to 9/4. Who is going to share for letter A? Go ahead and get started. Is 10, go ahead.
10/8 is not equivalent to 9/4 because they don't line up on the number line.
They do not line up on a number line. That's good. How else, with some sort of operation, can we explain this?
Like you can put a mark through the equal.
Okay. Good. Explain to me why. Emma, help Brentley explain to me why.
Because if you do 2 times 2 on each, then like it's only the bottom, the top one. You have to do whatever you do to the top.
Whatever, everybody? Whatever you do to the top, you must do to the bottom. And so, if we do 4 times 2 to give us 8, 9 times 2, it does not work, right? So that means they are unequal. They are not the same. Very good. Who's got B? Go ahead, Jackson.
16 times 10 9/4 are equivalent.
Are or are not?
Or not.
Why are they not?
Because if you draw a number line and you draw it into 4 pieces, but then you have to make like 2 more number lines and like 1 more, then you have to add another piece. So then it will equal more than 9 out of 4. But then once you do the same thing for another number line, same length, which is 10 out of 10, they do not match up.
These two things are not going to match up on a number line. Do 4 and 10 have any sort of multiplication relationship whatsoever? 4 times nothing equals 10. We got 8 and we got 12. So when we're talking about 4s, is 10 a hit or a miss?
Miss.
It's a miss. It doesn't work. And then look at 16 and 9. Does 16 and 9 have any sort of mathematical multiplication relationship at all? No, because on 9, we've got 9, 18. Is it a hit or a miss?
Miss.
It's a miss. So it's not going to be equivalent. It's not equal. Very good. Who's got C? Well, who's got it in their book? Izzy? I think it's Izzy, isn't it?
Yeah.
Yeah. Remember, I assigned these to people. Go ahead.
9/4 is equivalent.
Prove it.
Because they're on the same spot on a number line. And then what I was thinking for the relationship, for the 18/8, if you just times 9, 2, if you do 9 times 2, that equals 18. And if you do 4 times 2, it equals 18. Or you can do it, like you can divide it, like 8 divided by 2 equals 4.
Huh.
And then 18 divided by 2 equals 9.
Huh. You are the first person to say that on the review slide today. Interesting. Why does that work, Izzy? Why am I allowed to do that?
Because whatever you do to the top, you must do to the bottom.
Right, but over here I multiplied 2, and over here I divided 2. Why am I allowed to do either or? Why does both things work?
Because they both still add up. It's basically just kind of like flip-flopped, kind of, but with a different like sign.
Huh, kind of like opposite?
Yeah.
Huh. Interesting. Very, very interesting. Who did I call for D? Trenton?
27th and 12th are equivalent to 9/4 because if you times 9 by 3 it equals 27, and if you multiply 4 by 3 it gets 12.
Excellent, which means these things are equivalent. Everybody give Brentley, Jackson, Izzy, and Trenton 3 big claps. Here we go. Great job. Very nicely done. Let's talk about today's review slide. Here we go. Today we're going to be talking about factors. And we remember our discussion yesterday.
Factors
Are the rainbow. The multiples are the list. When I start listing multiples of 12, I'm going to start with
12.
I'm going to count by
12.
Go.
12, 24,
36, 48. Good. If I want to list factors of 12, every single factor in the whole wide world has the same first factor. It is 1. Every single factor in the whole wide world has the same last factor. It is itself. In this case, is 12. What do I try next? 2. What goes with 2 to make 12, Bobby? 2, 4, 6, 8. What goes with 2 to make 12?
3.
2 times 3 is 6. I want 12. Help him, Dominic.
6.
The answer is 6. 2 times 6 equals 12. Next, we're going to try 3. Is 3 going to work, Cameron? 3 times 4. Are we going to try 5? Are we going to try to put a 5 right here? No. Because these go together. These go together. These go together. That's my rainbow. If I try to do 5, my rainbow's going to go like that. And that's not what I want. Correct? Correct. This is my factor rainbow. If you can remember that the factors are the rainbow, the multiples are the list, your factors always start with 1 and end with whatever number you're working on. The multiples start with itself. Count by itself. Okay? Let's find equivalent fractions by working with numerators and denominators, shall we?
Yes, we shall.
There you go. Which one doesn't belong? 30 seconds of think time. Shh. Silent think time. Silent think time. Two minutes of talk time with your table. Go. Talk to your table.
wait, I'll say the wrong. Yeah, it was D. I'll say.
That's too cool. It's not C, it's D. It's right there.
Class?
Yes.
What do you got? Someone raise their hand. Who wants to share what your team talked about? Alea. Why do you think D, Alea?
Because it has a 2.
Whoa. Who else said with their team that the N has a 2? Who saw that? Nice. Good eye. Very nice, Alea. We think D does not belong because it has a 2, right?
Mm-hmm.
We agree. D does not belong. Did anybody think anything different than D, or was D all we thought? Chloe?
I think it's A because if I look closely, it says 1/8, and the rest are 1/4. And you can split a D in half to make it make it one whole.
So, split this in half. That makes one whole, which means this dot is what?
1/4.
1/4. That looks like 11/4, doesn't it? 1/4. So, Chloe, you think A. Is she right about that? She is right about that. Does anybody? I saw JC holding up the letter C like this. What do you think, JC? Why do you think C? What's different about C? Brinley?
It's not like a number line.
It's not like a model, right? It's just a number. So, what do we think about B? Is there a reason why B might not belong, Emma?
Because it's supposed to be 1/4, but instead it's 2/4.
So this here is the only one that is 2/4. This here is equipped. Well, this doesn't line. I tried to line this up to 1/4. Why doesn't it line up? Why, Jaden?
Because it's not equal.
It is equal actually. But Chloe?
It's because it's 8s. It's like split into 8s and those are
No. Izzy?
Because it's a model and it's not like.
No, it is. This number line is not 0 to 1. This number line is 0 to 2. This number line is 0 to 1. So that's not gonna line up like that. That's my fault. Okay.
I thought it.
Here is our lesson for today. Andre drew a number line and marked a point on it. Label the point with the fraction it represents. Who can look at this fraction and tell me what this point is? Anna, what do you got?
8/12.
8/12. Why 8/12, Anna?
Because if you count the spaces, it's 12. And
We're counting spaces, not ticks, right?
yeah.
We're always counting spaces. This is 12. And then
You count the spaces until you get to the mark, and then it's 8.
and that's 8 on those 8 spaces on the number line. Very good job. To find other fractions that the point represents, Andre made copies of the number line He drew darker marks on some of the existing tick marks. Let's label the darker tick marks Andre made on each number line. So let's look at this dark mark. What would this be? It's not going to be 1, 2, 3, 4 twelfths because we're only looking at the dark ones. How many dark tick marks are they? What does that make this fraction be? What's this fraction here, Dominic? No. Trenton?
1/3.
Why 1/3, Trenton?
Because if you count all the black marks, you get 1/3.
This is one whole section now. This is one whole section now. This is one whole section. You see what I'm saying? So what's this mark going to be? Cameron? 2/3. Very good. Which one of those fractions, if any, are equivalent with our first number line here? Gracie? 8 12. Oh, excuse me. 8 12ths and 2/3 are equivalent. What about letter B? What about letter B? We're only counting these black tick marks. So let's label this number line. Jaden?
12, 13.
We're only counting the black tick marks now, though, is the change. The change is we're only counting the black tick marks. Emma?
2, 3,
1, 2, 6. Look, we're only. You have to use the black tick marks as your number line now. So here we have 1 space, 2 spaces, 3 spaces, 4, 5, 6. So what's this tick going to be? 1 what? 1/2? Not 1/2. Cole? 1/6. 1, 2, 3, 4, 5, 6. Denominator is the total amount of equal parts. We have 6 equal parts here now. Landon, if this is 1/6, what's this mark? This is 1/6.
2, 6.
Good. What's the next one?
3, 6.
Next one?
4, 6.
Next one?
6.
And this one is equal to?
6, 6.
Good job.
1 whole.
Which one is equivalent to 2/3, Landon? Here's 2/3. Which one is equivalent to 2/3?
That one middle. 1, 2.
Honey, it's about the number line and where they fall on the number line. They have to match up on the number line. Which one's equivalent with 2/3?
4, 6.
4, 6. Good job. Now, as we go to the next slide, I need you to keep this number line situation in your mind. I'm going to come back to the slide in a second. We got to go over and read and come back. Chiron wrote the same fractions for the points as Andre did, but he used a different strategy as shown. Analyze his reasoning. What do you see there, Izzy?
I see that you can just flip it and it would be like 2 times 4 equals 8, but they used division. So it's now going to be like 8 divided by 4 equals 2.
Huh.
Kind of like I said earlier, for the daily review slide.
Exactly like you said earlier. 8 divided by 2 equals 4. 12 divided by 2 equals 6. 8 12ths divided by 4. Wait. Is that what he said?
Mm-hmm.
8 divided by 4 equals 2. 8 divided by 2 equals 4. Okay, I'll just use it. 8/12 divided by 4 equals 2/3 divided by 4 equals 2/3. Yeah. Okay. So okay. All right. So Chiron is using division. How do Chiron's division sentences and Andre's number lines kind of match up? Let me erase some of this stuff so you can get a better look. So you can get a better look here. How are these things related? How are these things related? Let's have 2 minutes of table talk. Talk to your tables, you're so excited.
I got it. 2 times 4 and 3 is 6. You just add 1. And look, actually, I was saying that. I don't know. I'm cereal over it. You just gotta flip it. Yeah, you need to flip
Oh, extra credits. Oh, okay, we'll talk about that in a little bit. Got about 30 seconds left. Keep talking.
I don't want to say it. Like, I don't want to say it. So you can calculate all
All right, what did our tables talk about here? What do you notice about the relationship between Chiron's work here with the division and these number lines? What do you think you notice? What do you notice here, Jaden?
They're equal. They're equal because on the number line they're at the same place as well.
The 2/3 and the 4/6 are equal, as well as 8/12 because they hit the same place in the number line. What else did you guys talk about, Tucker?
2 times 2 is 4, and 3 times 2 is 6. And if you look up there, that you just need to like turn it around, and it makes that. It makes it.
Oh, are you saying this? That's what you're saying.
Yeah.
You're saying that it's equal. Those are equivalent as well, right?
Mm-hmm.
Right. Hey, here's what I want you to see. Look here, 8/12 and 2/3. So we're going to look at this number line and this number line. Look here at this divided by 4. How many little 12ths is in one section of 4 of one section in the thirds column? 4. And look, it's divided by 4. Here, these are divided by 2. And how many 12ths are in each section of sixths, Dominic? 2. That's the relationship I'm wanting you to see, is the 2 sections and the 4. Now, let's see what we can do here with 10/12 and then separately with 10/12, yeah,
Mm-hmm.
and 18/12. can you get me an equivalent fraction of these? Who thinks they can get me an equivalent fraction of these? I know you can. I know you probably can. Gracie, why don't you lead us and see what you want to do?
I know 18 12.
Okay, what are you going to do with 18 12?
And then I divide it by 2. And 18 divided by 2 is 9. And then 12 divided by 2 is 6.
Very good. Everybody give Gracie 2 claps. Very good. Tucker, you want to try the next one?
It's 24 because 10 2 times is yes.
Yeah.
You could whatever you do to the top, you must do to the bottom.
Good job. Could we also do something with division here? Could we do something with division, Trenton?
Because 10 divided by 2 is 5, and 12 divided by 2 is 6.
So then we have 20 24ths, 10 12s, and 5 6, all of which are equivalent to each other, correct?
Yes.
Very good.
And if you do 6 2 times, that makes 12, and 5 2 times, that makes 10.
That's right. So what he's saying is like, you could do times 2, 2. You go backwards here, right?
Mm-hmm.
Right. All right. We talked about all this already. Here we go. Get your cactus notebook out. Find at least one fraction. You only have to do one of these. So I want you to choose one of these and find an equivalent fraction to it. So, like, you're going to take one of them. So, say 5/4. You can do whichever one you want. This is what I want your paper to look like. You can do whichever one of these you want. 5/4 equals what? This is what I want to see on your paper. 5/4 equals what? And we'll choose 2 people to chat. Here I come. I'm going to check your paper off. I'm going to give you a check. I want to see if you can see what you do. Raise your hand when you're ready for me. When you're ready for a check. Here it comes. Oh, yeah, okay. You're multiplying. That's fine. Good work. Good job, Landon. Yes. Nice job. Go get tissue. Go get tissue. Good. Ready for a check, Kate? Oh. Once I've given you your check, you can put your Chromebook and your cactus notebook into your backpack. You're not looking for which 2 of those are equivalent. I want you to just pick one of those fractions and then create whatever equivalent fraction you want. All right, so here's a couple ways we could do this. 5/4. Can we do any kind of division with 5/4? We can't do any kind of division with 5/4 because 5 divided by 1 equals 5. We can't do 1. So we could do multiplication here, Bobby. Multiplication. And what do you want to do, Bobby?
Times by 2.
Times it by 2. 5 times 2 is?
10.
10. 4 times 2 is? 8. What was the mistake?
That
Did you multiply or add? Add. Stinking symbols get me confused. Very good. Let's do this, or let's do like 16 eighths. Can we talk about 16 eighths for a second? Can we use division to get an equivalent fraction for 16 eighths? What can we divide? Dominic?
8 and 4.
You can't. How did you get that?
Because if you just take away 1/8 on the 16 and 1/4 on the 8 equals 8/4.
Yes, your thought is correct, and your thinking would get you the right answer on a test. What's he saying? Let's say it in a different way. Somebody take what Dominic's saying and say it in a different way, Emma.
1 whole is equal to 16/8 because 16 is half of it.
She's saying the same sort of thing. Cole, help us get it. Help us get here.
16 divided by 2.
Yes. Whatever you do to the bottom,
You must do to the top.
that was so sad and tired. Whatever you do to the top, you must do to the bottom. Thank you. Equals 4. So 16 eighths equals 8/4, right? The moral of today's story: to create equivalent fractions, you can use multiplication or division as long as whatever you do to the bottom, you must do to the top, right? Right. This concludes our math lesson for today, everyone. Well done. Whoops. Stop record. Okay. Here.